In this video, we have an interesting looking logarithmic equation. It's x to the power of log of x equals 100x. And I had to think about this a little bit, and to be honest, I just decided to try to take the log of each side just to see what would happen. It turned out to work, so I was lucky that that was the first thing I tried worked. So I'm going to take the logarithm of each side. Let's take the log of x raised to the log of x equals the log of 100x. All right, at this point, we are going to use properties of logarithms. So when you have the log of something raised to an exponent, you can take that exponent and put it out front and multiply it by the log of that something. So let's write that log of x multiplied by this log of x. And what does that equal? Well, now we have to use another property of logarithms. Log of 100 times x, that's the log of a product, equals the sum of two logs. So we have log of 100 plus the log of x. Now this is starting to look a little bit like a quadratic equation in that we have something squared equals some constant plus something else that's not squared that's unknown. Before I read it as a quadratic, I'm going to substitute here, and instead of saying log of x, I'm going to use y. So I'll say, let's let y equal log of x. So instead of writing y times y, I'll just write y squared. Log of 100, that's just a constant. You could type it into your calculator, log of 100, or you can do this one in your head. 10 to what power equals 100? Well, it's 2. So log of 100 is 2, and then plus log of x, but again, we're going to write log of x as y. We have a quadratic. I'll kind of clean this up a little bit. Subtract 2 and subtract y from each side. So we have y squared minus y minus 2 equals 0. Let's factor that. That's y minus 2 times the quantity y plus 1 equals 0. And that gives us a couple of mini equations, I like to call them. Y minus 2 equals 0, or y plus 1 equals 0, or in the end, I'm going to move this up here, then we'll do something with it. Y equals 2, or y equals negative 1. Okay, now let's substitute this back in. Y equals log of x. So instead of writing y, I'll write the log of x equals 2. Equals 2. I'm thinking base 10, which is why I wrote that 10 there. Log of x equals 2. And the other mini equation, log of x equals negative 1. So the log of a number can be negative. You cannot take the logarithm of a negative number. So you can never say that x equals something negative in this type of equation. You cannot take the log of a negative number, but the log of something can be negative. And here's what this is saying, is that, remember, the log, when the base is not written, it's implied that it is base 10. I don't like that color. It doesn't show up as well. So it's base 10. So to evaluate this logarithm, 10 to the second power equals x. 10 to the second power equals x, or that is x equals 100. There's one of our solutions. Let's check another one here. 10, log base 10 of x equals negative 1. 10 to the negative 1 equals x. 10 to the negative 1 equals x. I'll write that out explicitly. 10 to the negative 1, that is 0.1. So 0.1 equals x. So those are the two solutions. Of course, you would want to plug each of these into the original equation to make sure it's not a false solution or something. But I'll leave that up to you because I know that these are the answers. All right, I hope that helps.